In this section, we're looking at geometry, where we're looking at congruent and similar figures, right? So quickly, here we have the word congruent, right? And congruent actually refers to um, same shape, right? So we're looking at same shape and size. So we're seeing the same shape and the sizes are the same. And the symbol for congruent is actually this, right? Where when things are similar, they do have the same shape, but the size may not be the same. So we have different sizes a lot of times, right? And then the symbol for similar stuff will just be that, all right? So in this case, this here, we're dealing with two congruent shapes, which means they're the same size, the lengths of the sides are the same, angles and everything. All right, so the information was given here when it says that ABCD, this here is referring to the fact that it's congruent to RSTU, right? So ABCD with R. Most times when you're given those, you could actually look back at how the letters are set up to make sure you match them. But for example, the fact that they say ABCD is congruent to RSTU, they're already telling me that this is where A is going to be, this is where B is going to be, this is C, and this is D. Why? Because when things are congruent, we want to make sure that we put things in the right order so that we get that identical twin effect. So already I'm seeing that. Another thing that you could do is that you could say you select a part of the diagram that you think is exactly like the other one. For example, if I choose D here, if I look at the point D, it's gonna look exactly like U. So when I look at the shape, then I could just think of the D like the U, which means I could have just written D here, which means that you could see the D and the U. Even here, you're seeing it already. So what I'm suggesting here, I could write D there, and then I could go in one direction. So let us say I'm going clockwise. So I'm going to go like this. And when I go in that direction, I'm going to pick up the vertices from D. So while I move from D going clockwise like this, I'm going to pick up the vertices. I'm going to copy them onto the other diagram. For example, from D going clockwise, we have A. That means this R is going to link to A, but we're seeing it here. And then we move to B. That means this is going to be where B is. And then C is going to go where T is. So we are able to copy the moment we could identify one vertex and its corresponding vertex from the other shape. We could go in one direction and copy the other vertices onto it so that we can respond to questions like these. For example, angle A, I could just come back to my thing here. Angle A is the same. It is congruent to angle R. Angle C is congruent to the measure of angle T. Angle D is congruent to the measure of angle U. Now we're looking at the length of the sides. So that bar over the two letters suggests that from A to B, the distance. So AB is the same as RS. You're seeing it there. So RS is the same as AB. DA is the same. So DA is here. It is the same as UR. And ST, which is along here, it's the same as BC. Please bear in mind that you have to move in the same order of the points that you get. All right, let's take a look at this other one. Based on what we just did, you could just pause the video for a second and then quickly respond to these questions on the side here. All right. All right. So I'm suggesting that this is what you would have had, right? Now, you could pick on a particular part. So let us say we're picking on here where Z is, and we're linking it to T when we take a close-up look on these two shapes. So I'm going to copy T with 2 where Z is like this. Remember, I'm going to go in one direction. So I am still going clockwise, right? Which means I'm going to have to go this way, clockwise, right? So when I leave from Z, I go to Y, right? So which means T, so moving from T in the same direction goes to S. That means this is S, right? So Y and S. And then when I move from S, I go to R. That means X is R. So I was able to easily copy the vertices of one congruent shape to the next. Then I could respond to these questions. When you're responding to these questions, do not just put down the letters how you feel. You're going to match back each letter in the correct order. For example, it says triangle XYZ is congruent to, so you're going to have to say R, S, then T. So you have to go in the same order. So it's congruent to R, S, T, right? So it's congruent to that triangle from R to S to T. So we're going according to the original layout that we got there. All right. All right. So let's look at what they're asking. Angle Z is congruent to angle T. Angle R is congruent to angle X. Because we're just simply picking up the things as we see them. The side length YZ, the side length YZ, which is Y, hold on, YZ, hold on. YZ from Y to Z is the same as from S to T, right? So from Y to Z is from S to T. And then if I switch it around and said ST, I will have to switch this to ZY. All right, so I have to follow the same order, right? All right, so ST would be, TS should say would be ZY. All right, so whenever we have similar ideas, quickly, questions can be asked. All right, we just looked at that, so let's go to this question right here. When ideas are similar, what it is that there is a definite relationship with the two shapes, right? So let's take a look at this here. These are two similar shapes, right? And the symbol for similarity is this. And when they're similar, there is a scale factor that would have changed one shape to the next. The moment it is unique for all sides with their corresponding sides, then they are similar, even if it is one. And that is why all congruent shapes are similar, right? Now, let's look at what's going on here. So we're taking a quick look at these two shapes. So we are told here that triangle ABC from A to B to C is similar to DEF, right? So when they're similar, if you should take a ratio of the sides that it corresponds, we'll get back the same number. For example, AB, which is this, is, so AB is going to be linking to DE. So you could see AB here with over DE as a ratio, BC with EF as a ratio, and then AC with DF. We're seeing those as a ratio. So because of that, if we should pick up the length of the side, as you could see that we have here, 10 over 15, and then the next pair is 8 over 12, and then 6 over 9. If we should break them down by reducing them, we'll end up getting the same number. This number is what we call the scale factor. It is actually what changes one shape to the other. So it picks up one length and gives it the corresponding length for the next. Now, on that basis, we should be able to solve problems like this. For example, if I'm giving the fact that there are two similar shapes here, so we're seeing this, we're seeing that. We're also noticing that we got two corresponding sides, like we got this, we got this. They are corresponding length, right? And then I'm given this length BC, and then I'm asked to find the corresponding side for it. What we could do is to set up a quick equation linking the two ratios because they would produce the same scale factor. So if I say 20 over 16, it is going to equal to 12 over FG, which is what I call X. And from here, I'm solving a regular equation where I could cross multiply quickly. So I could say 16 times 12 is going to equal to X times 20. So X times 20 gives me 20X. And then if I multiply 16 times 12, I'll get 192. So if I want to find X, which is going to be FG, I divide both sides by 20. And I'm looking at a length of 9.6 meters. So when the objects are similar, we are able to utilize the concept of the scale factor to find a missing sides that correspond with one that is given.